So we are going to be working on notes and examples for 2.6. We're going to be proving statements about angles. So once again, I highly recommend that you get out your Chapter 2 and your Chapter 1 notes. So we spent several sections and got a lot of information about angles in Chapter 1. And now we're going to get quite a bit of information about angles in Chapter 2. So in our Chapter 2 notes, we're going to look at some new theorems. We have our properties of angle congruence. So the reflexive property, the symmetric property, and the transitive properties are all true for angle congruence. So when we are looking at these statements, our reflexive property would be where we simply state that an angle is congruent to itself. The symmetric property is where if we already have an angle congruent statement, then we can turn that congruent statement around. So we can switch it around. And our transitive property is probably the most challenging one because we would have to have two sets of congruent statements. So our first angle would be congruent to a second angle, and that second angle would be congruent to a third angle, and then we can create a whole new congruent statement. Get that to where you can see it. And then we can create a whole new congruent statement where our first angle is congruent to our third angle. So pay attention to our information. So in the reflexive property, it's just an angle congruent to itself. Our symmetric property is if we have a congruent statement, then we can reverse the order of the congruent statement. And our transitive property, we have a first angle congruent to the second angle is congruent to a third. So since they're congruent to the same item, our first and third angles must be congruent to each other. Our next one is a postulate that we actually talked about in Chapter 1. So when we got our definition of a linear pair, we talked about this postulate then. So if two angles form a linear pair, so we're either going to have a diagram showing us a set of linear pairs, or we're going to have a statement saying that our angles are a linear pair. Then we are going to get that they are supplementary. So whichever two angles are shown in our picture as a linear pair, or that we've been told are a linear pair, we can now say that those angles are supplementary. So if I see or am told that I have a linear pair, then that pair of angles are supplementary. So don't forget that along with this one, you're probably going to want to look up the definition of supplementary, which tells us that we get a sum of 180 degrees. So to go along with this particular postulate, we often use the definition of supplementary. Our next one is kind of a common sense thing. It simply says all right angles are congruent. So if you have a set of right angles, then we can automatically say that they are congruent. So if angle A and angle B are right angles, then those two angles are congruent to each other. So if we know we have right angles, then they are automatically congruent to each other. This is easily proven with the definition of right angles and the definition of congruent. Our next two theorems are similar. They are congruence of theorems. One of them is with supplements, so congruence of supplements, and one of them is congruence of complements. They both start out in a very similar way, and they have a common ending. So in our congruence of supplements theorem, it says if two angles are supplementary to the same angle, and notice this little side statement, or congruent angles. So I would start out with a pair of supplementary statements. So angle 1 is supplementary to angle 2, and angle 2 is supplementary to angle 3. Then I'm going to get that they are congruent. Now, we need to understand, what do I mean by they? I'm talking about the angles that are supplementary to the same value. So the two angles that are different from each other in those supplementary statements are the ones that are congruent. So I'm going to get that angle 1 would be congruent to angle 3. So if you're supplementary to the same thing, then you're congruent to each other. Our next one is going to work with complementary. So if two angles are complementary to the same or congruent angles, so this time you're going to have two complementary statements. So our first angle is complementary to our second angle, and our second angle is complementary to a third angle. Then they are congruent. And once again, the they that we're referring to are the two angles that are supplementary to the same thing. So our angle 1 would be congruent to our angle 3. So the challenge with this is we start out with supplementary or complementary, and we get congruence. So you start out with either one angle supplementary to another. So we have to have two supplementary statements, or we have to have two complementary statements, and from that we get a congruence. And then our last one is actually a theorem that we discussed in chapter 1. So we discussed the vertical angles theorem. It's shown up a couple of times. So vertical angles are congruent. So we're either going to be shown a diagram with vertical angles, or you're going to be told that angles are vertical angles. So angle 1 and angle 2 are vertical angles. Then they are congruent. So my vertical angles will be congruent to each other. So if I can see, or if I am told vertical angles, then they will be congruent to each other. So we're going to use all of our information about angles, and we're going to do proofs. So we're going to take and work with statements about angle congruence. So keep in mind that we have our linear pair postulate along with our new theorems. So in the first example problem, we have this rather complicated diagram. Sometimes they're going to tell us our angle in terms of number, and sometimes they're going to tell it in terms of letters. When they tell me an angle name in terms of letters, I'm going to see which identifying numbered angles it takes to create them. And we're going to use our knowledge about angles to help us answer these questions. So we're going to need to keep our angle knowledge, so our angle knowledge from chapter 1, as well as our angle knowledge from chapter 2. So in the given information, we are told that we have 3 angles that are all 90 degrees. So when I look at my picture, I see that the angle BHD is actually made up of the measure of angle 1 and the measure of angle 7. When I locate CHE, I see that that's actually made up of the measure of angle 7 and the measure of angle 6. When I locate the angle EHF, I see that this is actually the measure of angle 5. So all of these things are equal to each other, and they're all equal to 90 degrees. You also need to remember something else. From chapter 1, we had a definition of complementary angles. So complementary angles have a sum of 90 degrees, and we just wrote 2 addition problems that have an answer of 90 degrees. So we're going to have a set of complementary angles with 1 and 7, and we're going to have a set of complementary angles with 7 and 6. So that is actually going to be needed to help us out with this. So we have several angles that are 90 degrees, and we're going to use that given information as we go through our calculations. So in problem 1, we're going to locate angle 3, and we're going to locate angle 6. And I notice that if I put these 2 angles together, they do make 2 sets of opposite rays. So these are vertical angles, and we have a theorem which tells us that they're going to be congruent. So this means that they're going to be equal to each other, and this is also 42 degrees. Problem B, we're going to locate our angles. So in problem B, I'm going to look for BHE. So BHE is actually 3 pieces. So BHE is the measure of angle 1 plus the measure of angle 7 plus the measure of angle 6. And this is equal to 142 degrees. From this particular list of information, we are asked to find the measure of angle 1. So that means I'm going to need to do some substitution. So I'm going to use my information about the measure of angle 6 plus the measure of angle 7 from up here at the top. Those are 90 degrees, so I'm going to replace that with 90 degrees. So the measure of angle 1 plus 90 degrees is 142, and now it's just a matter of doing subtraction. So 142 minus 90 is going to be 52 degrees. So we use our angle addition, and substitution to find that the measure of angle 1 for this situation is 52 degrees. In the next one, we are going to use our fact about the measure of angle 1 and try to figure out the measure of angle 6. Now, there is a really simple way to calculate this problem, and then there is a more complicated way to calculate this problem. And our simple way to work with this problem is something that we just learned about in chapter 2, this congruence of complements theorem. If two angles are complementary to the same angle, so when I look at this particular problem, my angle 1 and my angle 6 are both complementary to angle 7. So I can actually apply my congruence of complements theorem. Since they're both complementary with angle 7, then my angle 1 is congruent to angle 6. So they're going to have the same measure, and they will both be 37 degrees. So because of this angle 7 being complementary to both of them, we use our congruence of complements theorem to get that they are congruent to each other. Otherwise, you would have to substitute and calculate and substitute and calculate in order to do that. So you would substitute the measure of angle 1 in to find angle 7, and then substitute the measure of angle 7 to find angle 6. Our last question in this set, we're going to work with angle EHG. So EHG is put together using the measure of angle 5 and the measure of angle 4 in order to create this 132 degrees. And then we're supposed to find the measure of angle 7. Okay, so here's the thing. My angle 4 and my angle 7 form two pair of opposite rays. So angles 4 and 7, because they form those opposite rays, I get vertical angles. So angle 4 and angle 7 are vertical angles, and according to my theorem, angle 4 will be congruent to angle 7, so they're going to have the same measurement. So this means that I can actually use my measure of angle 5 to help me calculate the measure of angle 7. Okay, well, we're a little closer. Now we need to remember about our given information. So don't forget all the way back at our given information that measure of angle 5 was actually given to us as 90 degrees. So we're going to do a bit of substitution. And I'm going to put 90 degrees in plus the measure of angle 7, and it's going to equal 132 degrees. And now it's a simple subtraction problem. So 132 minus 90 is going to end up being 42 degrees. So we have to use our angle relationships in order to calculate angle measures. For the next set, we are going to make a sketch. So we're going to make a sketch of the given information, and we are also going to label all of the angles that we can determine. So in our first one, I'm going to have adjacent angles that are complementary angles, and one of them is going to be labeled 42 degrees. So complementary means that they're going to have a sum of 90 degrees, and adjacent means that they have a common vertex and side, but no common interior. So I'm going to make two angles that are connected to each other. So I have a large angle that has been turned into two smaller angles, and these are complementary. So I need to indicate that they are 90 degrees. So I've labeled a 90-degree angle. I now need to put one of those is 42 degrees. So I label one section as 42 degrees. And I have one more thing. I can actually figure out this third piece. So we are still not finished with this problem because we can use our complementary, so our 42 degrees plus the measure of angle DBC is going to have to equal 90 degrees. So our measure of the angle DBC is going to equal 48 degrees. So now we actually have all of the pieces of this diagram labeled using our definitions from chapter 1. So this is using our definitions from chapter 1 about what it meant to be adjacent angles and what it meant to be complementary. So we used our definition of adjacent and our definition of complementary in order to do this. Okay, in the next one, we are told to draw vertical angles, and we have to have a measure of 42 degrees in our picture. So we're going to have to use our definition from chapter 1 about vertical angles. So we're going to use our information. Vertical angles, their sides form two pair of opposite rays. I'm going to draw my two pair of opposite rays. I'm going to put a 42 degrees in one of those. And now from chapter 1 and again in chapter 2, we have the vertical angles theorem telling us that they are congruent. So I'm going to do a little application of the vertical angles theorem to get that the angle across from it is also 42 degrees. And I also get to use something else. So also in chapter 1, we learned how to recognize a linear pair, and we have a postulate that tells us that they're supplementary. So I actually form a line with my 42 degrees and the angle beside it. So I'm going to use my linear pair postulate. And remember that supplementary is going to give me a sum of 180. So 180 minus 42 degrees is going to be 138 degrees. And now I can use this vertical angles theorem again to get 138 degrees from the other side of it. So we can actually figure out all four of the angles in this picture. We actually did a problem almost exactly like this in chapter 1. So this is just a matter of using our vertical angles and or linear pair postulate. So when I look at this diagram, my x value is for a set of angles that are forming a set of opposite rays. So I can use the vertical angles theorem. This means that they're going to be congruent, and congruent means they're going to be equal to each other. So I'm going to take the 4x minus 17, and I'm going to set it equal to the 2x plus 9. Now it's just a matter of, can we solve this equation? So if I subtract 2x and add 17, I'm going to end up with 2x equals 26. And when I divide, x is equal to 13. The y value also happens to be two sets of opposite rays. So vertical angles are going to form those two pairs of opposite rays, and our vertical angles theorem is once again going to give us that they are congruent, so they're going to be equal. So I'm going to take the 2y plus 15, and it is going to be equal to the 5y. So when I subtract the 2y, I end up with 15 equals 3y, and my y is equal to 5. So look for vertical angles and look for linear pairs. So when we have the two intersecting lines, check to see if your angles are across from each other to be vertical angles, or if they're side by side to be a linear pair. Vertical angles are congruent, so we set them equal. Linear pairs are supplementary, so we add them to equal 180. And now for proofs. So when we look at this, we are going to complete a proof. The very first step I do with every single proof is I go through the given information and I locate it all within my fill in the blank. So angle 1 and angle 2 are complementary is statement 1. So I'm going to be able to fill in that first reason with given. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Both of those pieces of information are in line 3. So I'm going to be able to fill in my reason for line 3. So very first thing is I go through and I locate all of the given information. Now that I have the given, I remember that whatever it is that I am trying to prove should always be the last statement. So I double check to make sure that my last statement is actually filled in with what I'm trying to prove. So we're going to take it a piece at a time. So we begin with complementary. So we start looking up all these things that we know about complementary. And back in chapter 1, we had a definition. Our definition says that complementary angles, the sum of their measures is 90 degrees. So if I look at my given, it has complementary, and my very next line has a sum equal to 90 degrees. I have the two pieces of my definition. So my reason, this is essentially my law of detachment. So my reason for this is that I was using the definition of complementary. And you do have to tell me that you're using the definition. We have theorems that talk about complementary, but this is the definition. If it's your vocabulary word, it's the definition of. So our next piece of information is telling us that we are supposed to use our definition of congruent. So I need to look through my notes, and we talked about congruent in chapter 1, and we're talking about angles. So I'm going to go and look up the definition for congruent angles. So the definition of congruent angles says that the angles have the same measure, and I have to use the letter M in front of the angle name when I write this. So I have congruent. So notice that we have congruent. So we are going to write equals. So we're going to change those congruent statements from line 3 into equal statements with line 4. So it's going to be the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4. So I use my definition of complementary to get the addition problem. And then from my given information, I use the definition of complementary to change that to angle measure statements. Okay. So now I get to the next line. And this next line happens to have an addition problem. So I need to start going and looking around at things that I can do with addition problems. And when I have addition problems, some of the places I actually start are the algebra properties. I have an addition property of equality that said if I start with an equal statement, I can add the same thing to both sides. So I look at my problem and I see if I have an addition on both sides of the equals, and I don't, so it's not the addition property. I also have substitution. So in substitution, if I already have an addition problem and I can replace with what it's equal to. So when we look at this particular situation, we're going to take the addition problem of line 2 and notice that all we're changing out is the measure of angle 1 for the measure of angle 3. And we can do that. Oh, wrong highlight. So I can do that because of my equal statement. So I can actually replace my measure of angle 1 with 3 because they are equal to each other. So I can do a bit of replacing. So any item can be replaced with what it's equal to. So we are going to do a little replacing. So I'm going to take line 2 with the information from line 4, and I'm going to just replace that one value. And because we're replacing, this is substitution. So I took an existing addition problem and replaced one piece. Notice in the next line that we're going to do substitution again. So we're now going to take this line 5, and so I notice I already have the 3. I need to replace the 2. So I'm going to replace the measure of angle 2. How do I get that information? I use my information of what it's equal to. My angle 2 can be replaced with the measure of angle 4. So I keep the measure of angle 3. I replace the measure of angle 2 with 4, and I still have equals 90. So substitution, I have to replace part of the calculation. Substitution is all about replacing one piece of a calculation. So according to the fill in the blank, it says we're ready to wrap up this problem. And notice what we've done. We now have this word complementary again, and it is preceded by an addition problem equal to 90 degrees. So if you recall, in chapter 1, our definition of complementary angles is that the sum of their measures is 90 degrees. Definitions work both ways. So if I have the addition problem, I can get complementary. And if I have complementary, I can use the definition. So I'm once again going to use the definition of complementary. So notice that we use the definition of complementary twice. Once when we went from the word to the calculation, and then again when we went from the sum to the word complementary. So definitions work forwards and backwards. So you can use them more than one way. Our last problem, we're going to create the entire proof. So 2 columns, statements and reasons. No one should ever leave a write a proof problem blank. Everybody can tell me 3 pieces. Here's the 3 pieces that everybody should be able to fill in. You should be able to begin the proof with your given information, and the reason you can use that is because it was given to us. So everybody should be able to start with what was given. If you're given more than one piece of information, you can break it up into multiple steps. So we start with our measure of angle 6 equals the measure of angle 7. So my measure of angle 6 equals my measure of angle 7. Also, everybody should be able to fill in one more piece. Whatever it is that we're trying to prove is always going to be our last statement. Now, I have no idea how long it's going to take me to get there, and I may have to move it or readjust my information, but whatever it is that I'm trying to prove should always be my last statement. So I should actually end when I can say that angle 5 is congruent to angle 8. So my goal is to state that 5 and 8 are congruent to each other. So we have no additional guidance, but everybody should be able to get this far. Well, so how do we do this? Well, we start to look at things. My given information is about equal measures, and my proof statement is congruent. Do we have anything in our knowledge that talks about equal statements and congruent statements with angles? And we recognize in chapter 1 that we do have something there. We have the definition of congruent, which allows me to switch back and forth between the two. So that's where I'm going to start. Since my final statement has a congruent symbol, I want to go ahead and get a congruent symbol here. So I'm going to apply my definition of congruent. And I'm going to go and say that my angle 6 has to be congruent to angle 7 because of having equal measures. Well, I now have a congruent statement, and I'm trying to prove a congruent statement, but my numbers are all wrong. So here's the next thing I'm going to do. I'm going to take and focus on the part of my picture that has angle 6 in it, and I see that it also has angle 5. And it turns out that angles 5 and 6 form these 2 pair of opposite rays, which happen to be vertical angles. So I happen to know a few things about vertical angles. I see that I have vertical angles. Both pairs, or their 2 sides, form opposite rays. And vertical angles theorem is going to tell me that they are congruent. So my vertical angles theorem is going to give me that my angle 5 is going to be congruent to angle 6. All right. I'm a little closer because now I have 5 at least in my proof, and I have 2 congruent statements that work with that. And we just talked about how our transitive, reflexive, and symmetric properties work with congruence and angles. And we have 2 congruent statements that happen to have a common value in them. So these 2 congruent statements happen to both talk about the measure of angle 6. So I can apply the transitive property. It can't be substitution. Substitution doesn't work for congruence, only the transitive, symmetric, and reflexive. But I can now make a new statement that my measure, or that my angle 5 has to be congruent to the angle 7. So my angle 5 and my angle 7 have to be congruent to each other because they're both congruent to angle 6. Okay, we're a little closer to where we need to be. So I go back to the picture again, and this time in my picture, I'm going to look at the section that has 7 and 8. And guess what? This has something very similar to what we had with 5 and 6. 7 and 8 also form a set of vertical angles. So we're actually going to use the vertical angles theorem again, this time with 7 and 8. So my angle 7 is going to be congruent to my angle 8. Left out part of my congruent symbol there. And if you're looking very closely, you will now see that we have 2 congruent statements that have angle 7 in them. Didn't want to do that. There we go. So if I look, I can have my angle 5 from line 4 and my angle 8 from this line, and they are congruent to the same thing. So there's that transitive property again, and that actually will lead me to what I'm trying to prove. So my angle 5 from line 4, my angle 8 from line 5, and since they were both congruent to angle 7, they're congruent to each other because of the transitive property. So you have to know what your rules, postulates, and properties are in order to be able to complete and write a proof. But everybody should be able to complete at least 3 pieces. You should be able to at least get the first statement, the first reason, and the last statement, because the first statement and reason are the given, and your last statement is always what you're trying to prove.